Okay, this time we've been asked to find the equation of a line that passes through two given points, two given ordered pairs. Again, I always like to start with a better y-axis than that, or even that. There, we'll just use that. Why not? It's the best my hand's going to give us right now, apparently. Okay, we got a point at -3, 7, and a point at -1, -5, so we're probably talking like a -10 to 10 scale as far as where I need to put the tick marks. And so -3, I'm kind of thinking 1, 2, 3 for about the size of those tick marks, and then 7 will be vertical, so 1, 2, 3, 4, 5, 6, and 7, so that puts our point on the grid somewhere up there for my -3, 7. Now my -1, -5, that'll be -1, so -1 here, -3, and 7. All right, so now I have 1, 2, 3, 4, 5 down, and so that's where that point is. And so just kind of some things I expect. I expect it to be a negative slope line, and I expect the y-intercept to be something below -5, right? Could be significantly below -5. Could be more like -6, -7 territory. But we'll see when we get it graphed, or when we actually get the line solved. We're not really graphing this. Okay, well, what do I need to graph a line? There's two different ways to come up with the equation for a line. Two different equations that we could use. We could use y equals mx plus b. That's my slope-intercept form. Slope-intercept. Or we could use y minus y1 equals mx minus x1. That's my point slope form. Now, truth is, it's probably the same amount of work to use either one of these forms. I think that the point slope form makes a little bit more sense here, but I think I'm probably going to work the problem both ways just to show that we can get the same answer both ways, and that it's really about the same amount of work. Well, if I'm going to use the point slope form, which I think is probably slightly easier, I'm going to pick one of those 2 points, and that'll be my point 1, right? And one of those 2 points will be my point 2. So I'm going to choose this point on the left to be my point 1, so that means I have x1, y1. And the point on the right, I'm going to choose to be my point 2. And so we'll call that x2, y2. And that'll be my point 2. How do I find m? How do I find m? M is my slope. So I find my slope, m. I need it for either form of the line that I'm working with. And I always tend to remember, I think it's kind of juvenile, especially for college class like we're teaching here, but I always remember it as rise over run. So I always remember this is the way I was taught long time ago, rise over run. And that helps me think vertical change divided by horizontal change. Well, the more technical way to say that would be change in y, because that's my vertical change, over change in x. We always use that capital delta for change in. Well, change in y, that always translates to y2 minus y1 divided by change in x. The change in always translates to x2 minus x1. So we kind of remember rise over run, that takes us to delta y over delta x, and that takes us to y2 over y1, or y2 minus y1 over x2 minus x1. Well, I know my x's, my x1, my x2. I know my y's, my y1, my y2. So at this point, I just need to put some numbers to this and come up with a value. So what's that going to be? That's going to be my y2 is -5, and my y1 is 7. And I like that those are adding to be large numbers, partially because I've seen this graph and I know that I've got a relatively large value there and a relatively large value there. So as I'm doing this calculation, the graph kind of comforts my mind that I'm doing this at least reasonably. Okay, now my x2 minus x1. My x2 is going to be -1, and then minus a -3. minus a negative 3. I don't know why I wrote 1 down, but that's my x1 over here, a negative 3. And I like that those aren't combining to be larger, because I know that my x values, they just range from there to there, right? And so I should get a 2 out, right? I should be able to count that pretty quickly. And it looks like negative 1 plus 3 is going to give me that 2. So you might as well write that down. I've got my 2 in the denominator because 1 minus a negative becomes positive 1. Negative 1 plus 3 gives me 2. 5 and 7, that's going to give me 12, but it's negative. So negative 12. Well, this is going to be negative 2 times 6 divided by 2. 2 over 2 is 1, right? 1 times 6 is 6. So the 2's go away, and I just get negative 6. So I get that my m equals negative 6. I needed that for either the purple method or the black method. I needed that for either the point slope or the slope intercept. So if I do this with the point slope method, which is going to be using the black ink here. All right, so we'll write that down here. That's going to be y, pen, not eraser, y minus, and instead of y1, I'm going to use 7, equals, and instead of m, I'm going to write negative 6 because I know what m is. And then I'm going to have x minus, and instead of x1, I'm going to write negative 3 because that's my x1 over here. Okay. Well, let's distribute the negative 6. So I'll have y minus 7 equals negative 6x. That's a positive 3 times a negative 6. So I'm going to end up with a negative 3 times 6 is going to be 18, right? Okay. Well, the last thing I need to do is I need to, let's use a different color. I need to add 7 to this side to get that to go away. But if I do it to one side, I better do it to the other side of the equation. Otherwise, it's not a true statement anymore. And so now I have y equals negative 6x minus 11. And I said that, yeah, we were talking about a very negative slope here and that it could be significantly lower than negative 5. So that does pass my gut check, especially with as far as that rough sketch, the axis is drifting left on us, kind of making it appear as though it should intersect closer than it actually should. All right, I like that solution. I'm also looking at the right answer in the book, and it says that I have the right answer, which is always comforting. Now, let's try to do it the other way, because I'm always a fan of knowing more than one way to get the right answer. If you don't have the back of the book, working the problem 2 different ways and getting the same answer is always comforting too. I'd find the slope using the exact same thing that I did in the blue method there. And so now I would have my y equals negative 6x plus b. And what I need to find is I need to find that value for b. And I need to think about how could I get it to where I have an equation where it's just b and numbers? Because then I could solve it. I mean, I have to have an equation in one variable to be able to solve for a value for that one variable with one equation. I have to have the same number of equations as variables, right? Otherwise I can't get a solution. Each one of those points that I have up there are points on the line. A point on the line is a point at which the equation is true. So it doesn't matter which of those 2 points I choose. If I put in the x value and I put in the y value from the same point, that equation will be true, which means I can then solve for b being the unknown. So let's just pick the same, negative 3 and 7. I'll put 7 in, so we're picking this point up here for the point that I'm going to use. And so I'll put in 7 for my y value, negative 6, and then I'm going to put a negative 3 in for my x value, and then plus b. Well, I'll have 7 equals negative times a negative is a positive. We already did 3 times 6 is 18 plus b. Now I want to get that 18 over to the other side of the equation. So I'm going to subtract 18 because that makes this go away, right? That goes to 0. But because I did it over there, I have to do it over here. I'm also going to flip this thing from right to left because I want to see it as b equals. And then it'll be negative 18 plus 7, which is the same thing as negative 11. And so if I take that value, plug it in for b back up there, I get y equals negative 6x minus 11, which beautifully is the same value I got working it the other way. You don't have to solve this both ways. You only need to pick one way to solve it. I'm just showing you how to solve it both ways because, you might choose one method, you might choose the other method. Either one works. They both work. I don't care which one you use as long as you use a correct method to get a correct answer. All right. Hope that helps.